Okay, so continuing on with checking random stuff off the list here. I'm going to be doing a little bit of reverse engineering work. This old PA is an interesting one because it utilizes these input modules. My theory is that inside the octal tube connection that the modules plug into is essentially going to 6 channels that all have the same type of input impedance, etc. And that these little boxes are essentially just converting from whatever impedance and loading, etc. Of the source to match to that predefined standard that's on these. And I've got one of the modules out, and it's the one that I want to move into another home. I've cracked it open here. The interface here is your typical 1/4-inch jack. It has the specs on the label. This is essentially, from what I can determine, a 500 kilo ohm input impedance to whatever's going on this side. And on this side we have an octal tube connector, and that's what's plugging in on the inside of the unit. We have tip and shield are connected into the circuit board here. And then we've got 3 lines leaving the circuit board and going to the connector. And on the connector, it looks to me like they're using the same pins here that used to be for the screen, the grid, and the cathode when used on a vacuum tube bottom. So it'd be this pin, and this pin here. I'm not sure exactly how closely they lined up to the previous thing that would normally be used for on, say, a triode, but I do note that there is a transistor on this board. I looked it up and it is an NPN, and let's see, part number on there is C2240GR, and that's just a simple little NPN transistor, but that means that this board must not be passive. It must be powered. So this board is not doing a unbalanced to balanced conversion, which means that the white, black, and red wires going from this board to the inside, that red wire might possibly be power to power the transistor. The black wire would likely be a shared ground between the unit and the shielding line going off to the high impedance input device, which means that the signal may be on the white line there. Now, to verify that, I think the fastest, simplest way to do it is going to be to potentially pop the case on this, see if I can get access to one of these modules, octal sockets, power on the unit, and do some voltage testing and see. I'm pretty confident on the ground pin, so I think I can assume that one, and then I can probe the other 2 and see if either one of them has a DC voltage on it. Okay, so that's the plan. That out of the way. This case off here. Can figure out what the pin out of that tube is, or that octal connector is, then I can grab another octal connection and recreate the power supply for that, and then go from there. Stamped metal. Sockets appear to be mounted to this, and it appears to be folded there. But I can get to the backs of them, so that's something. Nice power transformer, nice filtering. Back up in this general region. So a nice big transformer in there. Nice big output transformer as well. Solid state, of course. It's got to be our mixer. Nothing too fancy in here. Okay, so I think I'll turn this around. And the one that I removed was the bottom one. To make it a little bit easier to get to, maybe I'll remove another one of these. Just don't want the circuit itself changing my readings. Hopefully the case stays together. The old connections here are not as glued as they used to be. That wasn't the right screw, was it? Easily fixed. Okay. Yeah, okay, separated. I can reach in there and get it. Shielded metal boxes, basically. Now that I've got this out, I can sort of take a look at what's in here too. This one is model number HAU 60S module. So let's go take a look and see what that is. 60S. Low impedance transformer balanced 200 ohm input. So that's actually a nice little input box for a microphone or something, anything with your typical dynamic mic level stuff. And it does have a transformer on it. Let's see if we can get a manufacturer off of that transformer. This is to stop it from grounding out the shielding on the transformer to this conductive plastic case. I don't know why. So it says IT-419Y on that transformer. This one has 3 transistors in there, and it looks like the same number of lines, but not necessarily the same pins. Lost a connection. At least it's obvious where it goes. Let's catch it on video so in case it breaks completely we can find our way back. It was like that. So we'll be potentially moving this out of this case anyway. We'll get there. I still need to see those pins though. Okay, so that's with the notch down. Yeah, it matches. They're using the same exact pins on this. So it's keyed inside here so that the key is down, and I've got this set here with the key down, and it's the red wire is one that way, the black wire is one more that way from the top going that direction. It's hard to tell that on the camera. Just point at them here. So that's the red one. Using silver things to point at silver things. Okay, red one is there. Black one is there. Right there. And the white one is here. So that gives us some information as to where we should probe when we plug this stuff in to mains power, which I am doing presently. Setting my meter to voltage. It might be a little easier to see if I do turn this around though. For me. Probably for you too. It's fairly obvious looking at this where the ground is because they're kind of tied together. It's kind of obvious which one's going to be power because they're tied together. So our ground is likely here because there's a black line going from here to here to here, one going from here down to there, and that goes over to there and over to there. So every single one of these sockets, those are all tied together, and it appears that the same is true for that line. So let's see, which polarity around are we? Verify it. So it looks like that one is positive, and that one is negative. So we've got 23.83 volts on the meter. Now that's with no load, so it's probably a bit lower than that, but it gives us a good idea of what kind of range we're talking about. And that would make it so that this pin over here is our audio signal, the one that's separated away from the other two. I see that there are other sets of pins attached to one another here as well. If I just treat this as my ground reference, let me probe around here just a little bit. So that's my 24 volts. This one is a fairly solid 0.681 volts relative to this, and this one is starting to pull negative, so there may be some bipolar supply stuff going on here. You go up to the top one, check it to here. So if I go between those two, it gives me a nice minus 23.28. This is probably so that they can do some op-amp stuff. And if I go that combination, I get a very clean minus 24. So minus 24 minus 24. Let's put that back on the ground here. Okay. So treating that as ground, that gives me 24. It gives me nada. That one's a bit odd. It jumps up and then down again. Alright, so I'm going to put red there. Check those two relative to each other. That's 24. That's 24. So these appear to be some sort of ground, but there's a relative difference between them, so I'm not sure what's going on. But it's not bipolar. curious. I don't actually need those pins. Okay, let's see. 24 volts. So then I'm going to have to track down a tube socket or decide to remove it from the case. I'm going to think on that for a minute. And it's probably going to need some shielding. Yeah, I'm not entirely sure. This will probably be an optional front end for high impedance input option on the front of the preamp. We were looking at the microphone input transformer for it the other day. But a way to plug in a guitar would be good. And I happen to know that this module here, the one that I just had over here, the HU30P with the 1/4 inch input, happens to sound amazing. It's a fairly simple circuit. Oh, there it goes. The wires broke. Good thing we caught that on video. So, pin 3 was red, and the big blob is ground. I'm really leaning on kind of just moving this into the case and figuring out how to get it the supply that it needs. So I'm going to have a bipolar supply in that case of like plus 15, minus 15. So I could probably get a 24 volt difference in there somewhere. But I really need that shielding connected because the instrument cable going off to the high impedance input device is going to be relying on that shield. My power supply might end up slightly more complicated than I was hoping. That would kind of stink, but yeah, I'm just going to have to think about that for a minute. So that's it for the moment. I'll be back when there is more.